Hello, gentlemen. It's me, Miss Janani, right here. Alright, in today's lesson, I'll be covering with you this chapter on volume and surface area of pyramids, cones, and spheres. This is notes number 15, so get your notes ready and follow the lesson, copy down the notes as I go along. Alright, let's begin. Alright, let us start off by covering volume of pyramids. So fill in the blanks over here. Volume of pyramids. Okay, so what is a pyramid? A pyramid is a solid in which one of the faces is a polygonal base. Okay, so the base could be a triangle, could be a square, could be a rectangle, could be a pentagon, hexagon, anything, any polygonal base. And the other slanted faces are triangles, joined to the edges or the sides of the base. So a pyramid looks like this, okay, and it's got different parts. So the base over here, in this case, it is a square, right? This shape defines the name of the pyramid, okay? And the lateral faces are these triangles over here, okay? The triangular faces between the base and the vertex. Okay, so what's a vertex? The vertex is the top over here, okay? The point where all the lateral faces meet, where all these triangles meet, right? That is called the vertex, the tip of the pyramid, okay? Also known as the apex. Okay, then when they say height, it refers to the perpendicular distance between the base and the vertex. So this part over here, the perpendicular distance is called the height. And then when they say slant edge, it means the common edge between two adjacent lateral faces. That means this over here refers to the slant edge. Okay, and what is slant height? Slant height is different from height itself. Height is the distance, perpendicular distance between the base and the vertex, right, over here. Okay, but slant height is the distance between the vertex and the midpoint of an edge of the base. Okay, so over here is your base, right? And this, let's say, is the midpoint. Okay, so the distance between the vertex and this part over here. Okay, the midpoint of the edge of the base over here, this is known as the slant height. This blue line that I just drew is a slant height. And as you can see, it also forms another perpendicular line over here. Okay, and it forms a right angled triangle. So these are the parts of a pyramid you must know. Okay, now many of the students may confuse pyramid with prism because both words start with P, so it's common to confuse the two, but please don't be confused. A pyramid looks like this, right? Where all your faces, slanted faces are all triangles, and then you have one polygonal base. Okay, but a prism has, remember, a uniform cross section. Okay, so for example, a cuboid like this is a prism. Okay, when I cut this way, ooh, my drawing is not great. Okay, when I cut it, let's say I take a plane and I cut it this way. Okay, I'll keep getting the same shape throughout, right? I'll keep getting this uniform cross section throughout. Okay, when I cut. But then for a pyramid, when I take a paper or a plane and I cut, I will not get a uniform cross section, right? As I cut through the pyramid, what will happen? The cross sections keep getting smaller and smaller. It will not be uniform. So it is not considered a prism. Okay, so do not confuse the two. A pyramid is a pyramid, a prism is a prism. The two of them have different formula for calculating the volume. All right, okay, let's move on to the next page. So over here, we've already defined what's a pyramid. And then a regular pyramid is where the base is a regular polygon. Regular polygon means all the sides are the same, all the angles are the same. Okay, so for example, you can have a triangular pyramid. A tetrahedron is when all the edges are of equal length. Square pyramid is when your base is a square. Pentagonal pyramid is when your base is a pentagon. Okay, then you have different types of pyramid over here. For example, a regular pyramid here and an irregular pyramid over here. Okay, this one is a square. This one is a rectangular pyramid. Okay, So for a pyramid, if the vertex is vertically above the center of the base, it is known as a right pyramid. Okay. And then all these are where your vertex is not vertically above the center of the base, right? So these are known as oblique pyramids. Okay, just some names for you to know. All right. Now this question says, previously we've learned about prisms. Write down any two differences between a prism and a pyramid. Okay, so just now as I mentioned, right, for cross sections, okay, the prism has a uniform cross section. Uniform cross section for prism. Okay, but then for pyramid is a non-uniform cross section. All right. Then the sides for prisms, they are rectangles, right, at the sides. Okay, but for pyramid, they are triangles joined to the apex. Okay, or the vertex. So these are two differences. There's also one more. For the bases, for prism, there will be two polygonal bases. And then for pyramid, there's only one polygonal base at the bottom. All right. So these are the three differences between a prism and a pyramid. The main thing is the cross section. For prism, there will be uniform cross section, but for a pyramid, it's a non-uniform cross section. All right. Now, what is the formula for volume of prism? Now, I will leave the link to this visual proof in the description box, so please click on it and watch the video. Now, once you've watched the video, you'll realize that the volume of pyramid is basically 1/3 the volume of the corresponding prism. And for prism, we already know the volume of prism is base area times height, right? So for pyramid, it is just 1/3 of that. Okay, 1/3 base area times height gives you the volume of pyramid. All right, based on the proof that you just watched. Okay, so let's try this question now. In the diagram, VABCD is a rectangular pyramid. The rectangular base has length 8 cm and breadth 6 cm. Find the volume, or the height of the pyramid is 9 cm. Find the volume of the pyramid. So all you have to do is to apply this formula. So volume of pyramid is basically 1/3 base area times height, right? So in this case, the base area is just 8 times 6 is a rectangle. And then the height is 9. So the answer is 144 cm cube. Don't forget the units. It's all in cm, so volume is cm cube. Okay, next question. Example 2. OXYZ is a pyramid whose base is a right-angled triangle where XY is 7 meters, YZ is 4 meters. Given that the height of the pyramid is 5 meters, find the volume. So volume of pyramid is again 1/3 base area times height. So it's 1/3 times. Now the base area is a rectangle, right? I mean, it's a triangle in this case, right? So it's half times base times height. So half times 4 times 7. And then multiply by the height. Okay, so press calculator. You will get 23 and 1/3. When your answer is a fraction, leave it as a fraction. And all the units are meters, so this is meter cube. 23 1/3 meter cube. Very good. Okay, example 3. The base of a pyramid is a regular hexagon whose sides are 2 cm. So let's draw this hexagon. Now remember, a hexagon has 6 sides. since it's regular, all the sides are the same, right? And all the angles are the same. So they tell us that the sides are all 2 cm, 2 cm, 2 cm. All right. So how do I find the area of this hexagon? Because I need this as the base area, right? And then, of course, the height is 5 cm from the question. So in order to find the area of this hexagon, what I'm going to do is to divide it into triangles. So if I divide it this way, right, I realize that there are actually 6 equal triangles, right? Because it's a regular hexagon, so all these sides are the same. And basically, I will get a 2 cm, 2 cm, 2 cm. All these triangles are 2 cm along the base. Okay, let's just extract one triangle out. But before that, let's look at the angles of the triangles. Now, these are all equal triangles, right? And then you know that the middle is 360 degrees, right? The angle is 360 degrees because it's one full circle. So there are 6 triangles here, which means every angle here is 60, 60, 60, 60, 60, 60. Okay, then because it's a regular hexagon, the interior angle is 120 over here. And then you're dividing it by 2. That means this angle here, okay, I shade for you. This one is 60. This one is also 60. And then this is also 60. So basically there are 6 equilateral triangles, right? 60, 60, 60 means all the sides are also the same. So if I were to extract one triangle out, it's basically 2 cm, 2 cm, 2 cm. All right. Let me write this nicely. 2 cm. Okay, and the angles are all 60, 60, 60. So how do I find the area of this triangle? Now I draw a perpendicular down. Okay, and then what happens? This will become 1 cm here and 1 cm here, right? Okay, and then I want to find the height over here. So we have our favorite Pythagoras theorem. So using Pythagoras theorem, basically 2 square equals to 1 square plus h square. So I want to find the height over here, the perpendicular height, right? So height is basically square root 2 square minus 1 square. That's 4 minus 1, which is 3. Okay, so the height is root 3 cm. Okay, so once I have the height right, I can find the area of one triangle. Okay, so area of one triangle will be area of triangle is half times base times height. The base is 2 and the height is root 3. So it is just root 3 cm squared. That's the area of one triangle. But I have 6 of these triangles in a hexagon. So the area of the base, area of hexagonal base is 6 times root 3 cm squared. Okay, now I have the base area and I have the height of the pyramid, which is 5 cm. So how do I find the volume of the pyramid? I just use formula. So volume of pyramid is 1/3 base area, which is 6 times root 3, right? Times the height, which is 5 cm. Okay. Now this will definitely give me an irrational number because of the root 3. Root 3 is going to be an irrational number. So when I press calculator, I'll get 17.3205, etc. I just give my final answer to 3SF because this is irrational. So answer is 17.3 cm square bracket 3SF. Okay, this is an interesting question because you have to find the hexagonal base area yourself. All right, very good. Next question. The diagram shows a right rectangular pyramid VPQRS with where PQ is 24 cm, QR is 13 cm, and VR, which is this slanted edge over here, this is 6n root 29 cm. Alright, find the height of the pyramid. So when they say height of the pyramid, they're asking for Vn, right, which is over here. Let me highlight for you. This is the height of the pyramid, Vn. Now, as you can see, this is actually making a 90 degree with the base, okay? And if I just extract out one of the triangles over here, oops, how come I cannot shade? Like that. This actually forms a 90 degree triangle floating in the air, if you can see. Alright, so how do I find Vn? Now, in order to find Vn, I must know Nr also, right? But I don't know Nr yet. Okay, so in order to find Nr, I'm going to do this. I'm going to use the triangle on the floor, which is PQR. This is a right angled triangle because they already told us that it's a rectangular pyramid. So PQRS is a rectangle. All these angles are 90, 90, 90, 90. So let's use that first. Let's use that to find PR. So PR is equals to, okay, let me write out in terms of Pythagoras theorem, PR square equals to 24 square plus 13 square. So PR is equals to square root of 24 square plus 13 square. When I square root it, I will get 27.294688. Okay, all these are irrational numbers, so you can write it to 5SF. This is not the final answer, right? So you write it to 5SF. Okay, 27.294 cm. That's PR. Okay, but you need NR because you want to use VNR, right, to find Vn. Okay, so you will take half of this. Correct. So you'll take half of this to find NR. So NR equals to 27.294 divided by 2. Basically, you can use the 5SF or you can use this part, the 24 square plus 13 square square root. Okay, divide by 2, you get 13.647. All these are 5SF, 5SF. That's your NR. Okay, so using that, right, I can find out what is Vn because Vn square plus Nr square equals to your Vr square using Pythagoras theorem for the yellow triangle over here. So Vn square is what you need, which you don't know, right? Nr square is this answer over here, 13.647. When you square it, your answer is actually 186.25. Okay, and then VR square will be 6 root 29 square. Okay, so when you press calculator, 6 root 29 square is just 1044. So Vn square is equals to 1044 minus 186.25, right? And therefore Vn is the square root of this 1044 minus 186.25. The answer is 29.3 cm to 3SF. This is the final answer, so you can leave it as 3SF. But in case you need to use this for the subsequent parts, right, I will always write the 5SF answer first before I write the 3SF. So it's just 29.3 cm to 3SF. Alright, this is to find Vn. Oh no, there's no space. Okay, it's alright. We shall find some space over here. Okay, for part B, let me use a different color. Find the volume of the pyramid. Okay, so you know that it's 1/3 base area times height, and you know the height from this part is 29.287. When we do part B, right, we cannot use 29.3 because it's a rounded up answer. So we use the 5 SF value instead. Volume will just be 1/3 base area, which is 24 times 13. That's the rectangular base area, times the height, which is 29.287. Okay, so times 24 times 13, answer is 3045.88. Okay, you will get this, 3045.886, blah, blah, blah. This is an irrational number, so you have to give your answer to 3SF. So final answer is 3050 cm cube to 3SF. Alright, and you're done with part B. Very good. Okay, the next part is on the nets of pyramids. So this is to help us find the surface area of pyramids. Okay, so for the net of this one, right, there's basically either a square base or a rectangular base here, and then there are 4 triangles. Tung, 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 tung. So when you want to find the surface area, you just have to find the area of this base, which is either a rectangle or a square, and then you add the 4 triangles. Easy. Then for this one, the net is just a pentagon over here, and then followed by triangle, 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 triangle. All right, it's a bad drawing, but yep. Okay. Basically, the sides are all triangles. That's what they want us to know. This one, the base is a triangle, and then the sides are also triangles. So 1 triangle, 2 triangle, 3 triangle, and the base is another triangle. All right. Okay. So to find the total surface area of the different types of pyramids, basically they're just saying add the area of the 4 lateral faces and the base area. Okay. If let's say you have a square base, okay, over here, you add the 4 triangles, area of the 4 triangles plus the square base. All right, that's how you do it. Okay, a closed pyramid has a square base of length 12 meters. Given that the slant height of the pyramid is 15 meters, find its total surface area. Alright, so if you want to draw the pyramid out, you have a square base, right? Like that, 12 meter, 12 meter. And then you have a pyramid that looks like this. Okay, and they're telling you the slant height, right, is 15 meters. So remember the definition, the slant height is from the top to the middle of the base like that. So this part here is the slant height 15 meters. Okay, in other words, right, if you just extract out one triangle, this is 15 meters here. Okay, and then the base is 12 meters. So in order to find the total surface area, you basically have to take half times base times height for one triangle, right? So half times 12 times 15. But then there are 4 of these triangles, so you have to times 4. And then you still have the square base, which is 12 times 12. Okay, so you press calculator, answer will be 504 meters squared. All right. Okay, moving on with example 6. In the diagram, VABCD is a right square pyramid. So this is a square here, square, right? Dung, dung, dung. The square base ABCD has sides of length 2 cm. The lateral edge has length 2.7 cm. So lateral edge meaning this part here, like VC is 2.7 cm. So if I were to extract one triangle outright, for example VCB, this one is 2.7 cm, this is 2 cm, the base is 2 cm. So if I were to draw a right angle, a height down this way, this will be 1 cm, 1 cm here. Okay, and how do I find the height here? Basically, I have to use Pythagoras theorem. So 1 square plus h square equals to 2.7 square. So h is basically, might as well do it together. H is equals to 2.7 square minus 1 square. 2.7 square minus 1 square. And then you square root it. It is 2.5079. I'm going to write it to 5SF. Okay. So I need this height to find the area of one triangle, right? So the total surface area will be 4 of these triangles, half times base times height, 2.5079, plus the square base, which is 2 times 2. Okay, so final answer 3SF. All right, it will be 14.0319. So it's just 14.0 cm square to 3SF. Okay, 14.0 cm square to 3SF. All right. Next question, example 7. In the diagram, VABCD is an open rectangular pyramid. Open meaning it is the base is open. Okay. The rectangular base has length 8 cm and breadth 6 cm. Height of the pyramid is 9 cm. Find the total surface area of this pyramid. All right. So we have many parts to cover. We have the 4 triangles at the sides. Okay, and then we don't need the base because there is no base. It's an open pyramid. Now, take note that because this is a rectangular base, right, the 4 triangles at the sides are not of the same area. Okay, so let us extract one out. Okay, I'm going to call this part over here X. Okay, the midpoint of BC, let's call it X. Okay, so if I were to extract this triangle out, like so, this is V and X. This is a 90-degree, right? Over here, V and X. Okay, so NX is 4 cm. Right, over here is 4 cm because it's 8 divided by 2, this part over here. Okay, VN is 9 cm. So how do I find VX? Right, so VX using Pythagoras theorem, Vx square is basically 4 square plus 9 square. So to find Vx, I will take square root of 4 square plus 9 square. Press calculator. Is square root 97. Okay, let's park that one side first. And then I'm going to look at, okay, so this one was the red triangle here, V and X. Okay, and I found out what is Vx. It is square root 97 cm. Okay, now I need to find out for the other triangle, which is the one facing this way. Okay, look at VAB. For that, I need to find the height over here as well. So let's call this point Y. This point here Y. Okay, then I need you to visualize like that. Okay, so if I were to draw this triangle, it is V and Y over here. Okay, where Y is over here. So NY is 3 cm, right? Because it is 6 cm divided by 2. Okay, this part here is 3 cm. VN is 9 cm. And then we want to find what is VY. So once again, Vy will be, using Pythagoras theorem, 3 square plus 9 square. You square root that, you get square root 90. Okay, that's your Vy. So if you want to find the area of triangle VAB, right, you have to use Vy as your height. Okay, so let's write it out. Area of triangle VAB is equals to half times base times height, which is half times 8 times square root 90, right? And then if you press calculator, this will be 37.947 to 5 SF. Okay, and then you must realize there are two of those. So VAB is here, and then VDC is also the same area. Okay, then for area of triangle VBC, this is half times base times height. Base is 6, and the height is what we found just now, which is over here. Right, remember this Vx here. This is x. Okay, so for that one, it was half times base times the height, which is square root 97. So that one will give you 29.546 to 5 SF. Alright, so once again, there are two of these triangles because there's one here, VBC and VAD. So the total surface area will be 2 times of 37.947 plus 2 times of 29.546. There's no need to add the base because it's an open pyramid. So when you press calculator, you will get 134.98. Okay, so to 3SF, it'll just be 135 cm squared. Okay, this is a good question because there are different triangles in this pyramid. They are not all the same, so you need to be careful when you visualize this pyramid. Alright, example 8. A solid pyramid has a rectangular base of sides 16 by 14 meters. Given that the volume is 700 meter cube, find the height. Okay, so if you were to draw it out, it looks like this, right? This is your pyramid. This is 16 meters. This is 14 meters. It's a rectangular base. Okay, so they want us to find the height, right? So you know that volume is 1/3 base area times height. Base area will be 16 times 14. And the height you don't know, so let it be h. Volume you already know is 700. Okay, you press calculator for 16 times 14 is 224. Okay, then you multiply both sides by 3. You get this 224h. Okay, so h is 2100 divided by 224, which is 9.375. 9.375. This is exact, so you leave it as it is. Okay, do not make it 3SF because this is exact. Okay, find the total surface area. Now this one is solid, so it does have a base, not like the previous question, which was an open pyramid. This one is solid. That means it's closed. Okay, the bottom also exists. The bottom rectangle also exists. So how do I find the total surface area? Now, similar to what we did just now, we need to find this height over here. Okay, so you need to let this be x. Okay, let's call this v n again, and then x here. So Vn is your height, which is 9.375, right? This one you already know is 9.375. So how do I find Vx? Okay, so to find Vx, right, I know Nx is 8 meters because it's halfway over here. 16 meters here divided by 2, Nx will be 8 meters. So 8 square plus 9.375 square will give me Vx, right? So I need to square root it. Vx equals to this. Alright, I press calculator and I get 12.324. 12.324 meters to 5 SF. That's my Vx. Then for Vy, remember how to find Vy? Okay, I draw one line here. This part is my y. Okay, so if you look at the green triangle, this, okay, I draw again, like that, right? Vny. Vn is your height, 9.375. Ny is this part here, so that is 14 divided by 2, 7 meters. And then you want to find Vy. So Vy is just equals to square root 7 square plus 9.375 square. So a lot of Pythagoras theorem. You see how Pythagoras theorem is useful, okay, for such questions. And you square root it, you get 11.700 to 5 SF. Okay, so very similar to the previous question, you have two of these triangles, okay, and then two of the other triangle, right? So, and then you also have the rectangular base. So the total surface area will be 2 times of half times base times height, where if your base is 16, right, your height will be Vy, which is 11.700, then plus 2 times half times 14 times Vx, which is 12.324, plus you still have your rectangular base, which is 16 times 14. Woo, that's a lot. All right. So, okay, let's press calculator. You should get 583.7 something something something, right? So final answer is just 584 meters square to 3 SF. Okay, it's a long question, but it's a good question, and it's very similar to the previous one. Just that the previous one was an open pyramid. Okay, so you didn't have to consider the base. But in example 8, it's a solid pyramid, which means the base exists. The rectangle at the bottom exists. Okay, so that's why you have the additional 16 times 14 also. Okay, so the final answer is 584 meters square. Alright, good. With that, we're done with the part on pyramids. Please try these homework questions on your own. Question 1, question 2, question 3, question 4. Okay, try them on your own. And I'll see you in my next video for volume and surface area of cone. Take care, gentlemen, and study hard. Bye-bye.